Number 100, same tree. So we have a tree P and tree Q, and then we have to write a function to check if the tree is are the same or not. So if the tree is the same, so we have to the same structure and same value for each node. Okay, so for my approach, I will let's say we have this solution here, so we guess we have 1 2 and 3, and right here is 1 2 3. So we will go to on by the left from the tree. So if from this node we have two more value, which is 6 and 7. Here is 9 and 10. Okay, so the same to go here, 6 and 7, 9, 10. So we will go from the top of the tree, and then we go to the left one, the most left one, which is exactly for the second tree, and then we will check. Firstly, we have to check if this node is null. If it's not in null or not. So if this thing is null, so we have to check to the other one if this thing is other one is null too. So it's mean that our tree have the same structure, so we will be able to return true in for this situation. But if this bracket is null, but the red one tree bracket is not null, so it means that it doesn't have the same structure. So it means we have to return false in this case. Okay, so the third situation is that if we have the same structure, we have to check the value is the value is the same or not. If it's not the same, we just return false, and if it's the same, we just return true. And then we go exactly right into this right subnode into the right here, and then compare them too. So we have the same structure and the same values, so this is true. And then after that we will use the Boolean logical. So we already know that if we just return false once, so it means that two trees are not the same. So only one false. Okay, we only not just one false only. So we use the Boolean or logical right here. So we use and logical. So you may know that if this thing right here true and true and false, so our output will be false. Only one false and the entire logical it will be returned false. Okay, times for solving this to the code for implement. So we will use Python, and first thing is the first situation is that the tree have the same branch or maybe structure. So it means that if P is none, and q is none, we return true. Well, it's just like I say, so 1 1 aka noon. So if this things right here and this things right here is on is noon, so it's mean that our left one of the tree is correct, so we just return true. But if but what if this this things right here is not noon but 6, so so this is not noon. This is not equal to noon, but the left one on the second is noon, so it's mean that our 2 3 doesn't don't have the same structure, so we have to return false. So in this case we will use all, so if p is none, on q is none, return false. So because we already checked if 2 not or is known or not at the first, so we don't we might don't get error if we write like this. And then the first situation is that you have to check the same value. Let me say a comment here. Are they have the same value? If p dot file is equal to key does it equal to key dot file, return false. So we already write down our 3 situation, and then we just apply this boolean logical, which is a little bit recursion too. So we have a return self dot is same tree, p dot left and q dot left, and right, which is a recursion, so it will move from the top one to the left one for port 3, and then we just need to compare them, and then we go to the right one until we reach the top. So let's see. Okay, there we go. Okay, time for complexity, because we're using recursion right here, so we have increase with space and time. So because we're using a recursion, so recursion, in this case we have pick up n space, because in the worst case it will stack n. We will have to stack n function. If in the worst case, it means that we have to go through all of the tree in here. So it's meant that similarly to here, it will have a big of n time too, because recursion in worst case you have to visit on the node on the 2 of 3. So it means that we have to visit on node. So we have here is on n o n.